Hi, today I'm just shooting a really quick video on kind of what I've been working on the past few years, just off and on. One of the items is this STM32 VHF radio. This was really one of the first things that I did that was actually a complete package that actually got digital audio onto RF. A couple of design things that I really wanted to do with this is I actually wanted to end up with a full 8-watt HT, and the analog devices I see just didn't quite get there. There was a lot of spur submissions on the output on this. They do have a newer part now that actually has a external VCO, which I may revisit this at one point. But what this has been great about is actually showing that it is possible to design your own DSP based RF radio that can do data as well as analog audio to digital audio. Previous designs that I've done, I've actually had the AMB codec board with a AVR, and then eventually I moved almost everything that I do now is an STM32. It kind of got started with this board. I did a lot of the development for the codec board that I did for my combo star with this board using basically this development board, WaveShare. They have a really nice peripherals package. They send you basically this board with a core module, all the schematics, basically tell you how to, if you wanted to redesign this in your form factor. It's really easy to do. They also give you a nice codec board to get your audio in and out. These worked really great. I still use this from time to time. This is a little bit older core module. One of the things I've been working on lately is this, I guess what they call it is a disco board, which is STM's new processor. It actually has an integrated display. All my previous designs have been either an Epson display controller or a Solomon Designs display controller, and the Solomon actually ended up fairly well. I mean, it worked really good. I actually ended up with a remote display working over CAN bus, and I could tune my radio and actually have something remote that I could basically put in the bedroom and mount my radio out wherever I wanted to mount it. And continuing with that, I've kind of noticed, I mean, we have a really good design for HF radio in the Pica Star Combo Star line that's fairly open. That does use an analog devices DSP. It would be fairly trivial. I think the STM32 SDR folks have already kind of proven that, at least for single sideband and basic operations of what that analog devices chip is doing in real time, the STM32 could actually do the DSP functions and replace that part. But what's on the Combo Star is very, very hard to find. I've done quite a bit of development with the old visual DSP analog, and it's not a really great development environment. The newer one, from what I've told, is actually much better. They have more common tools. I haven't personally used it yet, and the big thing is it's about it's really similar price to the STM. So that's kind of a multi-pronged approach of getting DSP functions to actually be the part of the radio behind the intermediate frequency stage of the radio. There are several VHF, UHF radios out there. DSP-10 is very similar to what the Combo Star is as far as how the stages are set up. One of the things that I'm looking at is, it would be possible to actually take a display based unit that is basically all your radio controls and have open modules that are basically radios in different bands, and combine those to where you could actually have basically a remote head for a home unit, or miniaturize it later and make it to where it can go in vehicles. I do know from my Kenwood radios that I have in my truck, it's way easier to mount a remote head than it is to mount another radio. One of the other cooler things that could be done is many of the radios that already are designed for remote head, you could actually design design a commercial radio interface for that remote head. The Kenwood 710, back in a previous video, I basically showed how the pulse counter works on the microphone control. All the communications between the head unit and the other are serial data. The GPS that it's using is serial data. And it also does have a 6-pin data port if you actually wanted to do digital audio and have that converted, and it would be really nice. But that's one of the things I wanted to touch on this video. Kind of all the parts are there. This was a great test bed for seeing what could be done. This ended up being basically a VHF do everything. The only issue that I really had was with analog audio. This really doesn't have a really nice interface. It has kind of a kludge that you can do analog audio on, where you're actually able to modulate the signal. It doesn't work that great. And that may be, the design or what have you, but it really wasn't, the chipset really wasn't designed to do that, but it does offer something. The receive is way better than the transmit side, but it does work. There's several guys out there that have actually improved on that design. It continues to be improved. I think the H-mode mixer, I believe Fairchild makes a little bit better part. It's a little bit different setup, but there's a lot of different options now, and I'd really like to see kind of all that meld together into a head unit, RF module units, and really kind of start getting codecs in the mix. The ambi codec's relatively easy to get now. For D-Star and things of that nature, but there's no reason that codec 2 could not be used on all of those platforms if you had enough synergy for someone on the far end to have a similar radio that would actually speak the protocol. And that's kind of the problem now. I'm starting to see a lot of free DV on HF now. Around in my area, DMR is very popular, especially within the last 6 months. The radios have come down way in price. So some of the things I've been working on is basically just coming up with a really simple DSP library for the STM32 to actually just do forward error correction and modems. I think as far as implementation goes, there's a lot of different implementations out there. Almost every spec that I've looked at, they've used different types of C4 FM or GMSK, and they're not necessarily standardized. So you would really need a software agile modem to be able to talk all those different protocols. I know a couple of people, I believe Connect Systems has been trying to do this for a while. I don't know, I kind of had some hope. A lot of those radios that are coming out of China now are STM32 based, and they are doing the ambi codec on board and not with an external IC. I've got a hold of several of those, and I'll be actually doing some teardown videos at some point. What I'm really looking for is one of those radios to actually be fairly common to this, to where basically all of the modulation is actually exposed to that CPU, and firmware could be added to the unit that it was not something it came with, but it would actually allow you to control the radio and do a lot of interesting things with the radio without having to do a lot of hardware design. This particular board, this is on the blog. This was done in KiCad, and it's downloadable. Schematics, the board files. I think the only real change, or the only real error that I had, is the temperature compensated oscillator. It needed to go to pin 2 of this AD chip, and I made that change. But on these boards, I was actually able to just move the trace over, and it wasn't a big deal. Like I say, these work really great. The only issue is coming up with a design that's a little bit more high power. This basically, you can't amplify this over up to about 3 or 4 watts before spurs become an issue. On the actual GUI, I actually have a 3D printed encapsulated 7-inch display with this pretty much verbatim design of this STM32 Disco development board. I'm using CAN bus. It's inexpensive. Transceivers work great, and you can send high priority messages and override other messages, which is a lot of code that I didn't have to write to get what I wanted. But that's kind of the remote display unit. I'll be kind of probably pushing some stuff out. It requires some pretty advanced things. It's all surface mount. You're pretty much going to have a reflow oven to assemble one. It does have some QFN parts and really small things that have solder pads in the middle that you really can't get to unless you really want to take a lot of time and use hot air. But reflow oven, you can assemble a board in just in a few hours. You'd also need a 3D printer, as the board really is not designed to be outside. It has a lot of rotary encoders. And a lot of the rotary encoders look like this. Basically, they're mounted to the board. They go through the plastic. The plastic I actually did an open SCAD. It's kind of parametric in that I can add additional controls, scale up for different screen sizes, things of that nature. But these are, basically you can plop a couple of these on the board, do a silk screen, and end up with a really nice radio that you can control. That's remote, and you're kind of starting to see that. I think Flex Radio just announced at the last Hamfest, or last big Hamfest show, their remote head display, which is basically all of what was on the computer is now in an embedded platform, and I think that's kind of where everything's moving to. That's what I would like to see. My goal is to have a small RF unit, maybe dual band VHF, UHF in my Razor, which is a ATV or side by side, and at home have everything, HF, VHF, UHF, something that I can control from a small desk, maybe inside the house, that I'm in a comfortable surrounding and not out in the lab trying to talk on it, and then mount that radio where I want to mount it, and I think that's ideal. But like I say, these the design is basically just a bunch of small encoders, an STM32, a large screen. I did add 2 of the small SPI I2C displays, which are really great for if you have, if you do have more than one radio and you want to show additional information for each receiver. Those can scale up. You can actually add a lot of those. And one of the nice things about doing one of these radios is the peripherals that you can add. This is what actually went onto the HT unit, and in my combo star. This is this particular one's a Neo 6M GPS module. These are designed, if you're mobile, these work really great. The higher end one of this actually will output a reference signal if you actually get a high enough module. I don't remember which Neo that was, but it may be a 7 or a 6P, I'm really not sure. But there's some added benefits to actually incorporating some of this into the radio designs. Just to kind of give you an example, this is the small I2C display. These are really easy to talk to. I did a driver, and I think Adafruit and a couple other folks have drivers, at least for the AVR, and they're real easy to port over to the STM32 platform. These displays are really bright. They don't consume a lot of power, and they're really inexpensive. You can add several of them on a display, and there's no reason on a really small radio like a small mobile, this may be your primary display. I keep looking out for multimeter that has this, and so far Agilent's the only one that has one, and I believe they chose amber. But these look great. So to end this video, basically, just kind of get people thinking about, what's next. And I think a lot of the folks are looking for, codec 2 and an actual ham protocol for digital past D-Star to surface. And I think pretty much what that's going to take is some really easy to use hardware that people can kind of get a hold of and get going on it. My first stab at that was with this. I mainly have used this for data for really extreme testing, just sending data from one location to another here locally at my house, and it's worked out really well. It didn't quite get the power that I wanted, but this works really good for a software development platform for doing whatever the new ham protocol is going to be.